Hello there and welcome to Complanner Studies, your YouTube channel that gives you the latest, up-to-date and easy explanations about subjects relating to science and technology. So we'll be covering digital logic design today. So if you are new, don't forget to like the video, share, subscribe to our channel and tell your friends, your classmates about this YouTube channel that gives the easy explanations for topics related to DLD. So in today's video, we'll be covering how to convert from base 10 to base 8 to base 2, 8, and also to base 16. And let's get into it. So we'll be solving examples. Let's start with the first one. It says convert 33 in base 10 to a number in base 2. In our previous video, we saw how to convert numbers in base 2 to base 10. Now we want to see how to convert those numbers back to base 2. So 33 in base 10 we have 33 in base 10 and we want to convert it to base 2. So when converting from any base to base 10, we use multiplication. So when we want to go from base 10 to any base, we're using division, the opposite. So we are dividing. So you want to draw a straight line, like draw a cross kind of, and put the number in base 10 here. So depending on your target base, what base you want to convert to? Is it base 8? Is it base 2? Is it base 16? So you have to answer that question. In this case, in this example, it's base 2. So we're going to be dividing this number by 2 until it can no longer be, until we get 0, but we're going to keep on dividing until we see 0. Now, 32 divided by 2 is that's supposed to be 16, right? Like 16, and then you have a remainder of 1 because 2 times 16 is, you know that 2 times 16 is equal to 32, and that's 1 off from 33. You just need there's a remainder of 1 after the division. You have a remainder of 1. So when you divide 16 by 2, you have 8 and you have no remainder. So you have no remainder because 16 can be perfectly divided by 2. So we're basically taking note of the remainders, this part, taking note of the remainder as we divide. So when we divide 8 by 2, we have 4, and there is no remainder again, it's perfectly divided. When we divide 4 by 2 again, we have 2, but no remainder again, perfectly divided. You divide 2 by 2, you have 1, and there is no remainder. And then we have to divide again by 2. We keep on dividing until we see a 0. So 1 divided by 2, as in 1 divided by 2. So as we all know, 1 cannot be divided by 2 because 1 is less than 2. So what do we do here? We write a 0 and we put a remainder of 1. That means it cannot be divided. So the remainder is just the number 1. Now, from the remainders, we are going to obtain the answer in base 2 by reading these remainders from the bottom to the top. So we go from bottom to top. We read it like this. So if we read the number like this, we will see that 33 in base 10 is equal to 10001. So 10001, 4 zeros, 1, 2, 3, 4. So four zeros and then a 1 in base 2. And that's our answer. We move on to the next example. Example 2 says convert 22.75 in base 10 to a number in base 2. So I've got 22.75 in base 10. I've got 22.75 in base 10 and my target is to change it to a number in base 2. So I'm going to do this in two parts and then I'm going to join those two parts together to give me my final answer. First of all, I'm going to handle 22 and then move to the 0.75. Let's start with 22 first. We convert 22, the whole number part on its own, to base 2. As usual, we start by dividing by 2. So 22 divided by 2 is 11. There is no remainder because 22 is perfectly divided by 2. You put another 2 there and say 11 divided by 2. That is 5. Remainder 1. There is a remainder because 5 times 2 is 10 and 11 minus 10 is 1. So there is a remainder of 1 when you do that division. If we divide 5 by 2, 2 will go into 5 2 times and there will be a remainder of 1. 2 times 2 is 4, so 4 is 1 less than 5. So you can see that we have a remainder of 1. Divide 2 by 2, you have 1 remainder 0. Remember, we only stop when we see 0, so you divide that 1 by 2 again and you have 0 remainder 1, because you cannot divide 1 by 2. So as usual, we are going to use this number from the bottom to the top. From the bottom to the top. But this will give you the whole number part of the number, because this number has a whole number part and a decimal part. So this is only giving you the whole number part of your answer. We need the decimal part. To obtain the decimal part, this is the method we use. Write 0.75, that is the decimal part. 0.75, you write it here, 0.75. And then you're going to start multiplying by 2. Take note of that, multiply by 2. So multiply by 2. The base, multiply by 2 in this case. So when we multiply 0.75 by 2, what do we get? 2 times 5 is 10, right? Carry 1. 2 times 7 is 14, plus 1 gives us 15. So we'll write a 5 and carry a 1 over to the whole number side, and that 1 comes here. We write this 15, then we write 5 and then carry the 1 over to the whole number side, and since there's nothing here, well, the one you just carried over and reason that the whole number side. So that's how I do it. That's how I do the multiplication. So whenever you multiply by 2, you are not multiplying the whole number part by 2. You're only multiplying the decimal parts. Only the decimal parts are being used in this multiplication. For instance, when we multiply by 2 again, 2 times 0 is 0, and 2 times 5 is 10. So I write the 0, and then the 1 that is going to be carried is just going to be written outside here. That's it. Just write the 1 up here. And that gives you the answer. So how do we then read our results? That's the question. You read your results from the top to the bottom. The opposite of from the whole number part. So we are not going to exclude this. This one is not necessary. This one here is not necessary. It's the one here. You just have to write the one, the whole number part. So what is carried over is always written at the whole number part. What's carried over is always written at the whole number part. That's how you keep on multiplying. So we just have these two numbers here, 1 and 1. So what's my final answer? My final answer is, okay, let's write it. 22.75 and base 10 is equal to Now for the whole number part, I'm reading from the bottom to the top. So I have 10110, 10110 point. So after I'm done with the whole number part, I put the decimal point and I go to the decimal part, 11. I'm reading from top to bottom, 11.11 in base 2. And I successfully converted this number to a number in base 2. Moving on to example 3, convert 43 in base 10 to a number in base 8. So we want to convert 43, right? And it's a number in base 10 to a number in base 8. So we are using the same method, just that this time around we are going to divide by 8. So we ask ourselves the question, 43 divided by 8, how many times can 8 go into 43? Just like we were doing for converting for the previous example where we converted a number in base 10 to a number in base 2. So we're doing the same thing here. 42 divided by 8. That will give us 5, remainder 3. Because 5 times 8, or 8 times 5 is 40. 5 times 8 is 40. So 40 is 3 less than 43. 43 minus 40 is 3. So the remainder is 3. 3. So if I'm to divide 5 by 8, that cannot happen. It's going to be 0 point something. So we write 0, remainder 5. 0, remainder 5. And as usual, we are reading the results from the bottom to the top. We are reading from bottom to top. So that's the answer. We can now confidently say that 43 in base 10 is equal to 53 in base 8. Now we move to the next example, where we have 60.75 in base 10 to a number in base 8. Now we use the same procedure, same method that we use in base 2. We first of all pick out the whole number part, that's 60, and convert it to a number in base 8. Let's run through that. So 8 divided by 60 is divided by 60 divided by 8, that would be 7 times. 7 times remainder 4, I believe. Yeah. 7 times remainder 4, and we have 8 again. Now 7 divided by 8 cannot happen because 7 is less than 8. So it will be 0, remainder 7. And we are reading from bottom to top. So this is the whole number part of our answer, 74 point something. So what's the something? To get the decimal part of our answer, we take 0.75 and multiply by this around 8, the base 8. So doing that, 8 times 5 is 40. So 0, carry 4, 8 times 7. 8 times 7 is 56. So 56 plus 4 gives us 60. That gives us 60, so 0, 6. So as usual, we are supposed to stop when we see 0. How do we know that we have our answer when we see 0, 0? As in the previous example, we saw 0, 0. So when you see 0, 0, it means that you've arrived at your answer. And so we only have one number here. Before it's in 0, 0, I just have one number, 6. So it's 6. So using that, we see that 60.75 in base 10 is equal to 74.6 in base 8. And that gives us our answer, 74.6 in base 8. Moving on to example 5, where we have 185 base 10 to a number in base 16. Let's see how we can attempt that. 185 in base 10. And we want to convert that to a number in base 16. So here's how we do. We're going to convert using the same method, 185. We are going to divide it by 16 this time around, not by 8 but by 16. So 185 divided by 16, that will give us 11. If you use a calculator, you will get 11.5 something. That gives you the number there, 11, right? It's 11. So what is the remainder? To get the remainder, all we need to do is just punch in 185 minus 16 times 11. And you get 9. So 11 remainder 9. 11 remainder 9. So we proceed. 11 divided by 16. 11 divided by 16. Well, 16 is less than 11, so that's not possible. 0, so we've seen 0. Remainder 11. As usual, read from bottom to top. From bottom to top. And we get 11 and 9. Now, this 11 has to be converted to a letter. Remember what we said: A, B, C, D, E, and F. We are assigned numbers to these letters, right? 13, 14. In our previous lesson, in our previous video, we assigned numbers to them. So 11 in this case is B. So we write 185 in base 10 is equal to, so instead of 11, we are going to write B. So B9 in base 16. So there's our answer. And that brings us to our last example. It says convert 2,695.875 in base 10 to a number in base 16. So we're going to look at this and take it step by step. So we've got 2,695.875 in base 10. Now we want to convert this to a number in base 16. So we pick the whole number part first and handle it. So we draw this cross. So 2,695. We're dividing by 16 since the target base is 16. So once you do that, 2,695 divided by 16, we get 168 point something on your calculator. So how do we get the remainder? a point something, because it's actually 168.4375. So we want to convert this 0.4375 to a remainder, because we can't use that. So remainder what? It's very easy. You just do 2,695 minus 16 times 168. Very easy. So this gives us the remainder. The remainder is 7. We do the cycle again, divide by 16. On your calculator, it gives you 10.5, but we know that the answer is 10 remainder something. So it's 100. The remainder is just 168 minus 16 multiplied by 10 to get the remainder. That's 8. 8 is your remainder. And you divide that 10 by 16. You can't divide 10 by 16, so 0, remainder 10. And we're reading this from the bottom to the top. So this is just the whole number part. The 0.875. 0.875. You just write it down, and then we proceed to multiply by 16. So 6 multiplied by 5 is 30. 6 multiplied by 7 is 42. Plus 3. So we know that 6 times 7 is 42. Plus 3. Plus the 3 here, that's 45. And 6 times 8 is 48. Plus 4, giving us 52. Okay, so 52. So 2 here, and then 5 is carried over to this side. But we're not done yet. We have 1 times 5, which is 5. 1 times 7, 7. 1 times 8, 8. So basically 1 times 5, 5. 1 times 7, 7. And 1 times 8, 8. So we add them together like a normal multiplication. Adding these together gives, this is 0. 5 plus 5 is 10. So there's a 1 carried over here. 2 plus 1, that's 3. Plus 7, 10 again. 10, 10. Then we have, we carry a 1 over to this side, and then we have 1 plus 5, that's 6. Plus 8, you have 14. So if you look here, the decimal places only cover 3 digits, right? 3 digits. So 3 digits point. So we have a 0, 0, 0. Once you have 0, 0, 0, it means that's the end. And we only have should I say, 1 digit, because 14. You know that 14, A is equal to 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So this 14 here means E, 14. So we are reading from top to bottom, but there's only 1 digit E, so it doesn't really matter. Top to bottom for 14, that's E. So the final answer is, we have a 10 here. 10 means E. So we can write 295.875 in base 10 is equivalent to A87 point, the 14 here is E, point E in base 16. And with that, we come to the end of this video, the end of this lesson. If you enjoyed the video, it helped you understand how to convert from base 10 to base 2, 8, and 16 better, you can just like the video, share the link also, and don't forget to subscribe to our channel to stay updated on our videos. And also, don't forget to use the comment section that's down below to ask questions too. So I can answer them on Fridays and Saturdays. I'll be available to answer those questions. And that brings us to the end of this video. Have a blessed day.